Hello, my wonderful viewers, learners at home. You're welcome to Kaduna State Ministry of Education e-learning platform. And on chemistry today, we'll be discussing the topic acid, base, and salt. This topic hopes to be a series. Today, we'll be looking at acids. And basically, we'll be paying our attention on the definition of acid, and we'll be looking at the classification of acids. I'm sure that you have your pens and papers ready for today's discussion. If you're ready, I am ready to go with you. Let's start by defining what an acid is. Now, acids have been defined by different scientists, and we're going to look at the Arrhenius definition of an acid. And Arrhenius defined as acid as any chemical substance that when dissolved in water produces hydrogen ion or hydrozonium ion as its only positive ion. Now, if you look at the screen, you see an example of HCl. When HCl dissociates in water, it produces H plus Cl minus. The H plus there is the only positive ion, and that makes HCl an acid. On the other equation, you will see H3O plus, where H3O plus is hydrozonium ion. Now, apart from Arrhenius, there are other definitions of an acid, and we have the one that is done by LOWRY and BRONSTED. And LOWRY and BRONSTED define an acid as any substance that donates a proton. In other words, an acid is a proton donor. Now, if you look at the illustration on the screen, you will see Ha plus B, such that Ha reacts with B, where Ha is the acid and B is the base. Then if you look at the product, you will see a conjugate base A, then you have a conjugate acid B, where H, which is a proton, has been donated to B. And that is what Lowry sees, and he defined an acid as a proton donor. Now, apart from Lowry, we have what we call the Lewis concept of an acid. Yes, the Lewis concept of an acid. So Lewis defined an acid as an electron pair acceptor. In other words, any substance that accept electron pairs, and that is exhibited by ammonium ion. So if you look at the screen, you will see ammonia, and in ammonia there are two lone pairs of nitrogen reacting with HCl in such a way that one of the hydrogen in HCl will take the position of the lone pair of electrons, such that it will have a dative bond with ammonia to form ammonium ion. And that's when we say an acid is an electron pair acceptor, because the hydrogen there has accepted electron pair from nitrogen. And that's that about the definition of an acid. The next thing we'll be looking at is classification of acid. Now, how do we classify acid? Now, people have generality in classification of acid, but I'm going to classify acid based on their occurrence, based on their strength, based on amount of water or concentration, and the last one is based on basicity. Now, let's follow me and see how we can classify acids based on their occurrence. Now, based on occurrence, we say acid can be classified into organic acid and mineral or inorganic acid. When you say organic acid, you talk about acid that occur naturally. So organic acid are acid that occur naturally. Example of organic acid is lactic acid, and you can get lactic acid from your sour milk. A milk that is left to sour overnight, it becomes lactic acid. Then you have ascorbic acid. Ascorbic acid is gotten from vitamin C. Yes, when you take vitamin C for cold, or if you have an injury or stuff like that, the content is actually ascorbic acid. Now we have what we call methanoic acid. Methanoic acid is deposited on your skin or on your system when an ant or bee stings you. So you get methanoic acid from ant stink. Then what about palmatic acid from your palm oil, and ethanoic acid from fermented palm wine? I hope you get this properly. When you are asked to give example of acid and their sources, I'm sure this lesson will come handy and you'll be able to deliver. Now, the next one is inorganic acid. Remember, I say inorganic acid are acids that are manufactured in the laboratory using mineral resources. Example is hydrochloric acid containing hydrogen and chlorine, and the formula is HCl. The other one is tetraoxosulfate 6 acid. It contains hydrogen, sulfur, and oxygen, and the formula is H2SO4. Then we have trioxonitrate 5 acid. Some people call it nitric acid. Then it has hydrogen, nitrogen, and oxygen. HNO3 is the formula. Then we have tetraoxophosphate 5 acid containing hydrogen, phosphorus, and oxygen. And the formula is H3PO4. Now we are going to look at another classification of acid on another basis, and that is going to be based on strength. When we say strength, we are talking about two types of acid, the strong acid or the weak acid. Now, the strength of an acid is determined by the degree of dissociation in water, or how much of the acid can dissociate in water. When an acid dissociates completely in water or solution, is said to be a strong acid. When an acid dissociates partially in solution, is said to be a weak acid. Example of strong acid include HCl hydrochloric acid, tetraoxosulfate 6 acid, triogonitrate 5 acid, just to mention but a few. An example of weak acid include ethanoic acid. Ethanoic acid is CH3COOH. I'm sure you lay your hands on other examples, and they will be very handy when you are doing your examination or you have any questions coming on that. Then the next classification is based on concentration. Most times students confuse concentrated acid to be the same as strong acid and weak acid to be the same as dilute acid. No, it's not the same. When you talk about concentrated acid or based on concentration, you are talking about the amount of water in the acid. If the acid contains small amount of water, it's said to be concentrated. And if the acid contains large amount of water, it's said to be dilute. Let me draw your attention quickly. If you have a cup of tea and 3 cubes or 5 cubes of sugar, the tea will taste very sweet. That is a concentrated tea. If you pick the same amount of tea and transfer into a bucket full of water, you find out that the taste will no longer be there because it has been diluted with large amount of water. And that is it with acid. When acid contains small amount of water, it is concentrated. When acid contains large amount of water, it is dilute. I'm sure after this lesson, my student will be able to differentiate between a strong acid and a concentrated acid, and a weak acid and a dilute acid. Now, the last classification is based on their basicity. Yes, what is basicity? The basicity of an acid is the number of replaceable hydrogen atoms or ion in 1 mole of the acid. Again, the basicity of an acid is the number of replaceable hydrogen atoms in 1 mole of the acid, and hence acid can be classified into monobasic, that is having 1 replaceable hydrogen atom in the cases of HCl as example, HNO3 and CH3COOH, that means hydrochloric acid, triogonitrate 5 acid, and ethanoic acid. They are all examples of monobasic acid. Now, what about dibasic acid? Dibasic acid have 2 replaceable hydrogen atoms in 1 mole. Again, dibasic acid have 2 replaceable hydrogen atoms in 1 mole. Example of dibasic acid is H2SO4, that is tetraoxosulfate 6 acid. Then we have carbonic acid. It's not a very common acid, which is H2CO3. And just to mention, but if you have ethanoic acid, I'm sure you will lay your hands on other authorities and you will be able to get more examples. Then let's look at tribasic acid. Tribasic acid have 3 replaceable hydrogen atoms in 1 mole. Example is phosphoric acid. Phosphoric acid is H3PO4. My wonderful learners, I have enjoyed my stay with you. I wish we can continue, but today we will stop here. In our subsequent lesson, we will come across other aspects of acid. Join me on my YouTube channel, and you will have so many lessons to listen to, and I'm sure you'll be glad you did. If you like what you have heard or listened or seen, you can hit the subscription button and subscribe so that you can get further tips on my lesson. Have a good day, and God